We should be starting now.
Okay, then, so I'm joining session, I'm convening the session today, and welcome back, everyone. So we start with a talk about mplhep by Andrzej Novak.
All right, hi guys. So yeah, my name is Andrzej, and I'm going to talk about mplhep, even though it has already sort of been flashed quite a few times in a good number of talks, which makes me very happy. But I guess I'll go around over a summary of everything that's available. So the purpose really is twofold. The primary idea was for me or sort of came from me wanting to be able to make the same plots on my laptop, on the server where I was working, et cetera, et cetera. And so the idea was to basically easily distribute styles for MatplotLib and fonts along with them so that all plots can look the same. And thus basically just reduce the amount of, sort of silly overhead that I was writing every place that I wanted to just inspect a few histograms. And then secondly, because currently MatplotLib does not support histograms plotting very natively, because I suppose until recently there weren't many use cases where one would expect the histogramming to take a long time. So we have some functions to facilitate that. And so ideally, the hope is that at some point all of this would be absorbed into MatplotLib, but for now this is where it lives for convenience. And so, yes, as I basically already said this, that MatplotLib is not supporting this sort of natively, and so there are some wrappers. So just to showcase sort of what we're dealing with, a couple of silly imports, and this is basically the typical histogram we would be dealing with. So NumPy returns a tuple, and the tuple has value of bins and value of values. Well, sorry, array of bins and array of values. And these are mismatched by size, which is why sort of MatplotLib has difficulties dealing with that. And so the three typical ways this could be done is you can either get your bin edges and cut one of them off and add the differences. And then, so what this effectively ends up doing is you pass one sort of count in each bin, and that you weight the counts with the actual values. So this is a sort of one unpleasant hack that you can do. If you want to turn this into a stat plot, this is not fairly easy actually. But also alternatively, you can just want to plot the line, where again, you need to do some kind of adjustment for the variable number of the inputs. And so, oops, there we go. It gets even more messy if you want to include error bars. So this is the same plot as before, but adding some kind of square root of n errors. Oops, can do more things that I wanted. The problem is, again, that MatplotLib is not aware that this should be one thing, so you have to do a little hack where you store the artist and fetch the artist color to
Excuse
make this
me?
work properly. Yes.
Could you increase the font size a little bit?
Let's see.
Yeah, that's better.
I can, yeah, okay.
Perfect.
All right. Yeah, but really it should be a bit easier. So the idea behind this plotting helper is not something revolutionary, just basically wrapping all of these functions so that they are conveniently accessible. And so it takes a bit of a second to import. And so now you have a much nicer sort of plotting interface that you don't really have to deal with, where H is the input NumPy tuple. The only downside is you have to specify the axis because you cannot call this on the axis. But if you used Seaborn before, this is not anything out of the ordinary. Oops, there we go. The primary goal when sort of thinking about how to do this was to just stay maximally unobtrusive. So if you know how to use or have used hist in pyplot, histplot should behave as sort of intuitively as you'd expect, which again would allow an easy transition back to MatplotLib once this gets implemented natively. And so it's also desirable that all the quarks that you would expect to be interpreted by MatplotLib get passed through and work properly. So you can do something like this. This is the downside of having increased the size. So you can pass the hatch, you can pass the colors, etc., like exactly like you would in MatplotLib proper. And then there's some other things that you can do that are conveniences in hist that you want to be able to do as well. So if you pass a list of histograms, you want to be able to plot them together. You want to be able to plot a stack plot. You might want to take the density or norm the histogram separately. And then also basically want to make this as convenient for myself and for anybody else doing similar work. So some kind of simple function. So in this case, add 2 histograms like I did before. Add a mock data histogram, so just add the total size and redraw this from Browsonian. And then on the third plot, plot all of them together and normalize both of them to a unit area. So you can get a kind of a data Monte Carlo discrepancy plot that you would otherwise. Okay. One of the other things was to be sort of flexible about the input type so that users don't have to do any of the handling themselves. So you can pass a list of values essentially. You can pass the histogram tuple from NumPy, or you can pass this separately. And you can also unwrap it like this. So it all works just fine. And also thanks to recent pull requests from Henry, you can now do directly pass boost histograms, and you can pass output objects directly as well. So this is the th1 file, or root file containing some th1s. I guess prof is also a th1, so you can pass it directly to histplot. And similarly, if I just take the example from boost histogram README and add this, I can pass the object directly to MatplotLib. The other thing was for 2D histograms. So this was actually a little bit easier because the pcolor mesh function in MatplotLib almost does everything that we would want it to do. The only thing is that the indexing is a bit unintuitive if you wanted to plot a histogram. So basically the hist 2D plot is just a small wrapper on this and with some like extra features in the style of a heat map so that you can do annotations. So let me show you what I mean. Yeah. So I fill again a boost histogram object, specified that I want labels. By default, this will also plot a color bar because most of the time, if you want to see a 2D plot, you also want to see the z-axis. And then you can do the usual MatplotLib stuff. So for example, if you want to change the color map, you can. If you want to, for example, change the minimum value, you can do that as well, etc., etc. And again, you can also pass a th2 file. So that's pretty much takes me from all the plotting to the original primary purpose of MatplotLib, which was to serve and distribute styles. So I started with me just having a style for CMS work, but then we merged in a similar effort for Atlas, and recently there was also a contribution for an LHCb style. And also part of this is the sort of discussion that for plots to look the same, they need to be using the same fonts, except it's a bit tricky with fonts because they're under various licenses and distributing them is not easy. But one of the things we do here is that we package an open lookalike called textjar-heros, which looks very much like Helvetica, which lets us sort of ensure that the plots will look the same on any platform you run this. So here's an example. And so this is actually exactly the case of what I was just talking about. So if you look at this style object, you'll find out that it really is just a dictionary with the configurations. Oops, sorry. With the configurations. And in this case, the font array has the styles that were chosen for Atlas, but on this binder environment, Helvetica is simply not present, so you get some kind of a replacement. But the nice feature of this interface to MatplotLib is that you can also chain this. So you can, for example, simply override some of the configurations that are in the default styles to something that you would want to use. So if you mostly want to use an Atlas style, if you mostly want to use the Atlas style, you can, but you can also override it with some configurations that only you would want. Where's the missing? There we go. There's also this convenience label function, which really is a combination of two sublabels, the sort of left and right one, which one you can use them separately, for example, for something like this. And or really you can just, for I think 90% of the cases, the convenience function will be enough, because you can select if you want to plot data or not, which will determine if it's simulation. You can select if you want this to be paper or not, which will determine whether it's preliminary. If you pass luminosity argument, it will automatically put this. And so there's a similar function like this for CMS. And sorry, let me just cycle these so you can see a CMS style over here. And then a similar one for LHCb. And actually this will come up again, what I was discussing about the fonts, because the default font for LHCb is Times New Roman, but I tried to install core fonts in the binder, but it did not register properly. But if you do have your computer set to such that you have Times New Roman available, this will render correctly. And so I think I went fairly quickly over the allotted time, but I think that's okay. But just to summarize, I'm basically very happy that mplhep has already saved, I think, a good chunk of work to a number of people. It's already part of several publications, so it is a proof that we can in this way create plots in Python that are compatible with the experiment publication guidelines. Yep, that's pretty much it actually for me.
Yeah, thank you very much. That's very nice. We go to the presentations, which I will share, or will try to share. There we go. Okay, maybe I just read it off. So first question is, maybe I missed this, but does mplhep use MatplotLib's tag rendering backend?
So all the styles actually have a text sort of backup. By default, we went with using the built-in MatplotLib text renderer because it's sort of easier to play with. So for example, if you just use Arial as your chosen style, as long as the character is part of the font, even the math will be rendered correctly. But you can use text, but it takes a bit longer and a bit more tinkering. But yeah, by default, we try to use the MatplotLib text backend.
So do the experiment labels work if you're not using the tech backend?
Yeah. So
great.
So for example, the CMS one is actually the one that currently is labeled as CMS is the one that will work sort of the best if you don't have any of your fonts installed, because it uses the texture heroes that's being served that looks like Helvetica. Whereas the Atlas and the LHCb wanted to have the Helvetica and Times New Roman there primarily, but it's not possible to distribute them with the package because they are proprietary.
Okay, then I don't know how to. Okay, now it's back. Then we go to the next question. So, yeah, is there an interoperability between PyRoot and mplhep? Like, say, drawing a TH1 and passing it to mplhep?
We have not tested this, honestly, because I think even at a point, if I was already in the PyRoot environment, I would probably prefer to just make the plot in PyRoot because of how painful it would be to export it. But the way it is set up currently is that if you pass any object to the function that has a numpy or 2numpy function that generates a numpy-like histogram, it will plot it. So it might be possible.
Okay.
But so I don't know about PyRoot, but at least the uproot histograms work.
Okay, then the next question is, can you set any of these labelings as default, like paper true, so you don't have to order them for every plot? Same.
No, there's no way to currently do this. We don't have a. It would make sense to have some kind of a config that would read this. That's actually a good suggestion.
I remember that RootPy used the context manager setup, which is quite neat. Set up within a bunch of different plots. Could be something interesting.
Sorry, I think you dropped out for a second, or maybe just for me. Can you say that again?
I'll put it on Slack, don't worry. Sorry.
Okay.
Yeah, the comment was to use a context manager for this sort of thing.
So I'm not sure if I'll understand this correctly, but so there's a. Do you mean the with syntax or something else?
I mean, as far as I understood, people would like not only to set the style, it determines the plotting, but also some defaults of the mplhep commands, change the defaults of those via something like a style file. And this could be then in a context manager, so you only apply it locally.
Yeah, so there was actually some issue. So it is technically possible to write with plot plt style use and then write some kind of temporary settings. But this is actually limited because it doesn't work for fonts. So I didn't bother pursuing that further. But I think this could relatively easily exist in a way where you would set this default kind of like you set a seed in NumPy. So you just do mplhep.config.paper equals true or something like that. That should be easy to do.
Okay, then so I still don't know how this works. Okay. Yeah. So the next question is, the uproot and boost histogram integrations achieved via duck typing in some way, or does mplhep have a dependency on those packages?
Yeah, that's the first guess is correct. So we check if the object that's passed has certain methods, and then if the methods sort of behave as you would expect, they are plotted.
Okay, and the last question, so will mplhep provide at some point interactive plots as root is now doing in notebooks with JS root, or is that not on the menu?
I think this is not on the menu because mplhep is primarily here just to extend the matplotlib functionality. And I don't think there's any interactivity apart from maybe some digits that you could use just the same as you would with matplotlib.
You can just use what Matplotlib apps though, right? I mean, because you can do the interactive or the widget mode.
Yeah, you can use the widgets, but not. I don't think you can have it interactive in the same sense that, for example, Plotly or Bouquet are interactive.